Hello everyone, this is Jay Prakash and welcome to my new set of video tutorial on machine learning, Spark, mlib libraries. And today we are going to see about Uber data analytics. So this is my use case and I want to analyze and find from the series of a set of cars, billions of cars, tied up together and that produces billions and billions of data, and for a day it creates, for an hour it creates 25 GB of data. And I want to, based on this all this data, I want to figure out what should be the ideal Uber's pricing and what is the correct the most beneficial pickup location to find the maximum profit for Uber. So that's been my use case. I will be doing my predictive analytics on, hey, my car, I need to stop it over here when I don't have a pickup, so that if I go to this particular location I'll be definitely getting some more number of pickups. So this is what's going to be my use cases, and to do this I'll be using something called clustering algorithm. And Google very interestingly using this use this technique called as clustering to group news articles into different categories based on title and content. So if you go to Google News, you see in the left there is multiple categories, and based on that you can select your news, and all these classification is based on the K-means algorithm which Google uses. And clustering algorithm discover grouping that occurs in collections of data. So let's see what is this K-means algorithm. This K-means is one of the simplest unsupervised learning algorithm that solve the well-known clustering problem. So what is an unsupervised? Uh, let's see that in the next video. It follows a simple and easy way to classify a given set of data through a certain number of clusters. So it creates a number of clusters. So whenever you feed the data, so you decide the number n. So if you give 100 clusters, it is going to create 100 clusters, and there is something called centroid based on the data. It creates an average or mean of data, and a centroid is at the center of a particular cluster. So it creates a centroid, and every time actually the data is being fed into this model, and it is being done in an iteration. So whenever a new set of data comes in, the centroid is automatically repositioned, and once after all the data is being processed, centroid stops its repositioning, and each centroid will be surrounded by a number of values, and each cluster will be holding those values. So this is what the K-means does. Automatically the data is grouped based on the centroid and clusters. So each cluster will be holding some number of data. So that's what this classification technique does. So K-means is one of the most commonly used algorithms that clusters the data points into a predefined number of clusters. So you give the total number of clusters, you decide it. And clustering using the K-means algorithm begins by initializing the coordinates to the K number of centroids. That's what I said. With every pass of the algorithm, each point is assigned to its nearest centroid based on some distance metric. Usually it is Euclidean distance. So whenever the new data source is being fed, it either goes to one of a centroid, and if it not been in the specific limits, the centroid automatically recalculates its position. So the centroids are then updated to the centers of all the points assigned to it in the past. This repeats until there is a minimum change in the center. So it stops beyond a point. That's what is exactly said. So I use a data set from this particular link. So this is where I picked up the data set. You also can go and get it, which I updated it over here. And this is the schema of my data set. It has a date and time, the time and date of Uber pickup, the latitude of the Uber pickup, the longitude of the Uber pickup, the base, a TLC company affiliated some information, and it is in CSV format. And this is one sample record of my Uber dataset. So what I'm going to do is I'm going to feed the input for my algorithm as my latitude and longitude. Based on this latitude and longitude, I'm going to create a number of clusters. That's what I'm going to do. Um, that's what I'm going to feed my input for my k-means model. So let's deep dive. We need to invoke Spark Shell. I'm going to use Scala as my API for working on Spark, and you need to include this package when you invoke your Spark Shell in order to make sure your API to understand the machine learning library stuff. I mean, this is for invoking the Spark CSV. So if you want to recognize a CSV file, you must include this package when you invoke your Spark Shell. So let's invoke the Spark Shell. Before that, I'm using my Hortonworks 2.4, and I connected my Hortonworks using my putty. So just invoke my Spark Shell. It's invoking, and I did already coded the program, and it's going to automatically execute my program. So I already um, invoked my program uber.scala, which I'll be explaining in the subsequent slides what it does. So my program is loading, and let's see what it does. So in the meanwhile, let's go back to the presentation, and the first step what we do is we invoke the Spark Shell, my program along with the package to invoke the CSV, to just read the CSV file and process it. And the first step is import the packages needed for Spark, machine learning, K-means, and SQL. So you have to import all these libraries into your program. The second step is invoking an SQL context. So the entry point into all functionality in Spark SQL is the SQL context class. To create a basic SQL context, all you need is a Spark context. All these things at a deep dive level, we can see it in a separate video. But let's focus on what this Kmeans algorithm does in this particular video. So in the next two steps, imports, it's used for converting your RDD into a data frame. So you have to include these steps also. So we are going to invoke an data frame and perform some processing. We are going to load the data set into a data frame. So we have to import these two packages too. So this step, we are defining the schema for the input file. So it has four fields: date, latitude, longitude, and base, and these two are the fields. It has to be numeric. I mean, any numeric value only can be fed as input to this particular machine learning algorithm Kmeans. So both are defined as double. And load the data into the Spark data frame. This has been the syntax for it. So after I loaded it, I define a features array. So once after I create a features column array of latitude and longitude. I declared my latitude and longitude over here. I'm creating a vector array of latitude and longitude, and I'm creating a variable called assembler and initiating the vector assembler and creating a feature column called features. So I create a vector called features, and that is an array of latitude and longitude, and I'm transforming my original data set to a new data set to append the features column. So along with the existing data, I do have my features, that is nothing but my combination of latitude and longitude. So this is the important phase of this program. So you create a k-means object. So you create a training data and test data. So training data is where you will be feeding into your model, but test data is to just do some some kind of preliminary data analytics on top of it, and you do a random split of array of 70 to 30%, and this is the actual Kmeans algorithm syntax, and you set your total number of clusters to 8, and your input is going to be your features and output is going to be a prediction column. So the features is nothing but your vector of your latitude and longitude. Output is going to be each cluster. The prediction is nothing but a cluster. So you feed the data df into this model by using this fit command, kmeans.fit. You feed the data df into your model. Df is nothing but you loaded the data into this variable df. So this is the final cluster, final center. So each is actually a centroid. So it creates 8 clusters. Each cluster is having its own centroid. So by doing a for each print line, you see the centroid after all the data is being loaded. So use the model to get the clusters for the test data. So val categories model.transform test data. If you do that, so you'll be getting a variable got categories, and you'll be using the test data into these categories to do some preliminary data analytics. So this is what you do: load the data into the data frames, transforms it to features. So features is going to be your input, and this features is being fit to the model and transform into predictions. So once after the model is ready, you can ask multiple questions like how many pickups occurred in each cluster, which place had more number of pickups. So these kind of questions you can ask from the model, and it gives the predictions, and you can see the output of what it does. So it has created the data with the prediction column. Once after all the commands have been executed in the input program, I can show you my entire program, which I have uploaded in my GitHub. You always have access to it. I have uploaded it over here along with this presentation, which I'll be sharing this link in my YouTube channel also. So this is the entire code. So once after this statement categories.show, this is what is getting displayed. You get the cluster information. It is actually showing only 20 records, but each record it puts into a separate bucket, the cluster. So you have your model ready, and you can ask questions to your model like give me the count of records pickups in each category. So it's gonna give me the partition 0 contains these many number of pickups, 1 contains these many number of, so the partition number 5 has most number of pickups. So this gives a fair idea for the Uber drivers or Uber management to send more number of Uber cars to partition number 5 location area to maximize their profit. And we can ask another question. So what is the best latitude and longitude position, so that I send exactly my car to that location to make sure I get a pickup for sure. So if you see this particular latitude and longitude, 245 pickups have been happened, and the second most is almost close to that, 7818. So this is, even though the partition number 5 has most number of pickups overall, but the top 5 is being top 5 or top 6 is going to be your partition number 1, and this has been the exact location, almost close to each other. So if you want a pickup, just go to this location and get a pickup. So this is it for this video, guys, and I will be uploading all this documentation along with my code repository into my GitHub and sharing the link. And if you like my video, please subscribe and share it to your friends. And thank you so much, and we can see in the next video. Thanks.